Let me start. Okay, so I'm Chris. I'll be talking about F# open source, about a few F# open source projects, mostly connected with like tooling and getting like development experience better. So those are tools targeted for you as developers. You can find me on Twitter, on GitHub. I have a blog where I post sometimes something connected with F#. There's also my company, but that's like, never mind. So today I'm going to talk about like several tools which handles those four aspects of development and making them better and easier and more getting you more productive. Since most of you are not F# developers, unfortunately, but at least some of those tools works really great for all .NET languages, all .NET projects. So you should be able to use them in your existing C# projects or VB projects or Nermele projects or whatever else you like to use. And yeah, I just want to specify that building process is not about like compiling. Our beloved MS build is still there. It's more about like creating those complex build processes which contains compiling, testing, packaging, pushing stuff to GitHub, releasing Octopus deploy, and things like that. And all this will take 30 minutes, so I will not go too deep into any of those tools. I will not go to any technical details. It will be just like rough overview of features, and like maybe it will make you interested in one or two of those tools, and hopefully you will like investigate more after I talk. So I would like to start with Packet. Packet is basically F# application, console line application, which is created, which is open source, which is cross-platform, and basically it solves one problem, dependency management. In its core, it's alternative NuGet client. It also has few more features, but I will talk about it later. And what's important, for the NuGet part, it's only client, so you can still use same NuGet packages, you can still use same NuGet servers, MyGet, same NuGet infrastructure you have right now. It doesn't break ecosystem, it doesn't like split ecosystem into two parts like there were like people saying something like that. That's not true. It's just basically NuGet client which has several advantages or fix several problems of classic NuGet client. And first of all, it resolves always dependencies on solution level. So there is no possibility that you have JSON.NET 6.0 installed in one project and JSON.NET 7.0 installed in second project, and you have absolutely no idea why your program is breaking on the runtime because like MS build copied old version or something like that. So that's first big feature. Secondly, there is like no package versions in folder path. In packages folder, NuGet client normally puts hard codes version number of package in folder name, which is really annoying to deal from interactive environments like F# interactive and probably C# interactive. It's also really annoying when you like update packages on different branches and you have those crazy merge conflicts which are everywhere in whole solution because like version changes are in every project file in your solution. So Packet doesn't do that, it just uses package name and that's all. And that's safe because since there is only one version of package per solution, there's no any dangers of overwriting something or stuff like that. Next one, there is this concept on transitive dependency, which is basically saying that there exists indirect dependencies for your project. When you use normal NuGet, you specify that you depend on, let's say, Ionide or Ionide runner, and NuGet puts all dependencies of Ionide runner also to packages.config file, and there is no way of saying which packages are your dependency and which packages are your like indirect dependencies. So you cannot reason well about your solution, about your dependencies in solution. Next, it adds when conditions to the project files. So usually NuGet packages contain several versions of same DLLs targeted for different versions of .NET framework, like for example .NET 4.0, .NET 3.4, 3.5, or like portable class libraries and stuff like that. And when NuGet just normally adds right version for your project. And when you happen to change .NET version in your project, it's like everything breaks. And you need to like run NuGet again to update everything. And that's, again, just additional work you need to do. Packet handles that automatically by adding like when conditions to the project file. So it basically says when .NET version is this, use this DLL, and when .NET version is this, use this DLL. And last, like general feature is it support groups. Oh, I have typo, sorry. So basically this is similar to if you ever used Node and NPM, you know that there are development time dependencies and product dependencies. Like development time, it can be like testing stuff, building stuff, and things like that. Packet has similar idea, just pushes it a bit further. You can define as many groups as you want. You are not limited to only 2 groups. You can restore given group when you needed it. For example, on some staging server or something like that, you may not want to restore group which dependencies which are responsible for generating documentation or something like that. It really depends on your workflow. Also, Packets adds another ways to add dependencies to your projects. It supports GitHub for both project references and file references. It supports any arbitrary HTTP dependencies. If any file is in the internet publicly, you can add it as dependency to your project. It has full Git support. For the project references taken from GitHub or Git, Packet can build those dependencies for you, and it uses locally produced NuGet packages as source of your dependency. For the file references, it basically just downloads file to the packages folder and add those files to the project as linked files, so they are shared across multiple projects in your solution. All this is done using really simple, straightforward files which can be edited by hand. It's like not XML. It's not XML. It's not anything like with messy syntax. I will show it a bit later when I will be showing like whole demo of all those tools together. Next thing I will want to talk about is Fake. I know there was like lightning talk about Fake before, and probably some things will be repeated, but let's do this. Fake is basically built automation system. It's similar to like Psake for PowerShell, to Rake for Ruby, to Cake for C#, but obviously it uses F#. What's important is that it doesn't really require a lot of F# knowledge. You don't need to be like have 10 years of experience with F#. It's because it's basically like domain-specific language and a lot of helpers function used for building. It's provided out of the box. You need to learn something, those helper functions, but yeah, that's exactly the same in any other library for something like that. Basically, it lets developers to create small tasks and create dependencies between those tasks, which allows us to create those bigger, complex build processes, which can be used for many different things. For example, in one of my projects, we like compile F# to Java, run test, compile F# to JavaScript, packet, push to GitHub release, and also release it to Atom package manager register. So it's like really complex, big process, which is relatively easy to write. Especially for me, like I've never done a lot of DevOps. I'm a developer, and writing F# is just like writing this build script in F# is just like writing normal code. It doesn't like has these weird things that PowerShell does and stuff like that. And also, it's very old tool. It's over 5 years old. It's production ready, definitely. It's used in many projects. It's also not only F# specific thing. Well, you create build processes in F#, but it can be used for any possible .NET or even not .NET, as I've mentioned. It's like one of my projects is Atom plugin, and we also uses something which is basically Node.js based, and we are using Fake to create build process for it. So those are example of 4 big C# open source projects which are using Fake. Probably like few people contributing to it are here and may share their experience with us later about how they are happy with Fake. Almost all F# open source projects are using Fake. It's like community standard. Also, many commercial projects are using Fake, and it's often first thing which is introduced. Fake is often the first F# piece of code which is introduced to project or team or organization, because most of people or business doesn't really care what your build process is written in. They care that it works, and usually like even other developers in team doesn't really want to play with it. So if there's like someone using F# and volunteer to, yeah, I will create build process, cool, go ahead. Next tool I would like to talk about is Forge. Forge is a relatively new tool. It basically is focused on solving one big problem, handling project files, FS project files, outside of Visual Studio. As we've all noticed on this conference, there's a lot of like Visual Studio Code and other editors are really becoming popular in .NET. And handling FS project files is not super nice because like it's XML, it's like a lot of things you need to know how to edit it by hand. So this tool tries to solve this problem. It lets users to create new projects using a wide range of community-provided templates, from things as simple as console applications to as complex as using Swath web applications hosted on Azure Service Fabric. So yeah, like some complex stuff. It also allows to modify existing projects, add project references, remove project references, add GAG assemblies, remove them, add files, order files, which is really important from the F# compiler point of view. And also, yeah, that's mainly it. It also provides integration with Packet and Fake. Basically, if you create a new project using this tool, it's like using Packet and Fake out of the box. You can use some flags to disable this behavior, but we strongly believe that using Packet and Fake is way to go. And the last tool I want to quickly talk about, and then we will move to some demos, is Ionide. Ionide is a set of Atom editor and Visual Studio Code plugins for F# development. They are adding F# editing features like autocomplete, tooltips, finding references, stuff like that. All those nice features we know from Visual Studio or from Xamarin Studio to both those editors, Atom and VS Code. It provides F# integration with F# Interactive, so scripting environment, and those two things together makes it really viable alternative for Visual Studio to do F# scripting, because like you don't really want to start like whole instance of Visual Studio to just like write one script file or hack something. You can probably start 10 instances of Visual Studio Code during the Visual Studio startup time. But it's also worth noticing that Ionide is not only about scripting, it supports normal projects, normal solutions, multiple project solutions. Everything should work more or less, hopefully, without any problems. Yes, and a lot of emphasis we put on integration with Packet, Fake, and Forge, and other tools created by F# community to create this like lightweight, relatively lightweight development environment where like developers can be really like productive and do a lot of stuff they usually needed to do in Visual Studio or Xamarin Studio, but in different editors. In this case, those two. Okay, and now let's move to the demo. Okay, so as we can see here, we have like Visual Studio Code opened in empty folder with just gitignore file. Yep. And to do anything, we would like to create just new F# project and start doing something interesting with it. So there's this Ionide provides this F# new project command. You can choose product templates. In full version, there are more templates. I'm using like hacked version, which I was sure that won't fail without internet or something like that. So let's create console application, put it in a source directory. Let's name it .netfringe. And as you can see, so magic is happening here. Basically, like project is created, packages for this given template are downloaded by Packet, and yeah, that works. As you can see, we have here new project, which is basically like hello world application for the F#. Oh, we have autocomplete, well, tooltips. We also would like to add a new file to this. I will first initialize Git repository here. I've learned a lot during keynotes about communication, about good commit messages. So yeah. We would like add to new file to this project. So using normal Visual Studio Code UI, we click new file. We add test.fs. Again, great name for the file. And as we can see, it was automatically added to the project file. It is nice, but that's pretty simple. So let's move on. Yeah, I will just create here simple model. Something. Okay, and let's commit it again. Yeah, usually we would also like to create some test project for our stuff. Usually we like to write unit tests, so let's do this. F# new project, FS unit. FS unit is template using Ionide and F# library for making nice assertion called FS unit. Let's put it in test directory. Let's name it .NET-FRINGE tests. Again, some magic is happening here. And yeah, done. We have our amazing test project with two very complex tests here. This nice line is FS unit power. It lets users to create those assertions in really like fluent or human readable manner. It's not longer like assert dot equals and some like weird stuff. It's more readable for human. So like side point, testing is often other popular point of entering F# to the corporation, to the project, to the team. It's really expressive. It lets you write tests easily. It even lets you to give tests nice names, like we have spaces in this name, and it will be like detected by normal NUnit test runner or XUnit. So that's really nice. And again, people usually don't care about how you have written your test as long as they are here and they are testing something. Now we would like to add reference we would like to test our normal console application using this test product, so we need to add a product reference. Anyone knows how to add product reference by hand using XML and MS Build? Oh yeah, 3 people. That's great. Hopefully, luckily we have add product reference command. We choose product to edit. We choose product we want to add. Magic is happening. And yeah, here it is. We've added product reference to the product file, to the test product file. So yeah, those 4 lines of code, I have absolutely no idea how to write them by hand. I always needed to check it out in some other project. And with this tooling, it's relatively easy to just add stuff and have this nice user experience we know from Visual Studio in lightweight editor. What was that? Last one was 3, this one is 4. And now we can just here open .NET something and have this t variable as far as I remember. That's great. Everything is funny and yeah, it's working, but there's question, how do we run this stuff? And how do we compile it and build it and run those tests? Where is my green arrow to press and to just build stuff, build stuff? So here, that's part which fakes handle. When we've created project, we also created a really sample script file. Basically, those are targets I've talked about, those small tasks. These are just basic, really simple functions which do I think everyone can say what does this function. It's not really F# specific stuff. And here we define build dependencies. Here we say that deploy depends on build and build depends on clean, which means that whenever we want to run deploy, we want to run build before it, and whenever we want to run build before it, we need to run clean. Yeah, so let's use fake integration in Ionide. Let's build our application. Yeah, it starts build script, it restores packages if they are not restored, but that's not the case. And oh yeah, that's usual MS Build mess. But what's most important is that build succeeded, 0 warnings, 0 errors. So that's cool. And whole build process containing 2 steps, clean and build, also was successful, and we have some statistics. How does it work? And to run this, we can use terminal integration in Visual Studio Code. Go to cd build ls. And here we have our .NET Fringe.exe. Let's .NET Fringe.exe. Hello, Portland. Yes, and it works. It's basically Hello World program. But that was just compiling our simple applications. We also want to run unit tests. And here I need to do some magic, so that's not important. That was just basically error in template, which I need to fix. That was basically it. And to build and run our unit tests, we also add next tasks in the fake build script. So I've created some snippets for myself, so I don't make any demos to files. So that's basically saying where we want to put our test when compiled, what are our test projects. This basically executes MS Build, nothing really fancy. fake NUnit run. And this is a task which starts NUnit tests in this directory. Yeah, we have some problem here, but that's lack of system. Okay, and now we can do fake build, run unit tests. This will again try to restore packages if they are not there. It will build unit tests, okay, and run them. One test failed. I guess that's pretty expected, because this is like why it is expected. Well, t cannot be at the same time equal 42 and 43, so that's something we wanted to do. And as you can see, that's normal output of any unit test runner, so everything is there. How much time I got? 3 minutes, great. So that was fake integration. I also want to talk a bit about Packet. As I've mentioned, Packet defines its dependencies in really simple files. First file is Packet dependencies file, which defines source of your NuGet packages. There can be multiple sources here. And it defines top-level packages you are using. So that's your dependencies, your packages you want to use. You don't care about indirect dependencies. You don't care about any other stuff like that. This is file which is created one per repository or per solution. Second important file from Packet point of view is packet.log file. This file is a bit more complex, but it's automatically generated by Packet from the packet.dependencies file. You never need to edit it by hand. And it contains resolved versions of all your dependencies, including indirect dependencies with all versions, which basically ensures that your build is reproducible always when you use CI server, or it's ensuring that you will get same versions that are currently pinned on your GitHub repository. And third file is packet references file. There is always one packet.references file per project. It basically says which packages are used in these particular projects, which packets should add to this FS project file in this particular folder. And that would be mostly it. Few links. Obviously, there is one project with IO domain. It's obviously most cool. Yeah, but all those projects are pretty nice. Visit fsharp.org foundation if you want to know anything more about fsharp. I will upload this code to GitHub or something. You don't need to do photos. Also, I would recommend everyone interested in functional programming, or even not, to join fpchat.com. It's really nice community, really friendly. And that would be it. Thank you.